Welcome to today's session. In the previous session, we have seen our PWM. In today's session, we will observe our PPM, where PPM stands for pulse position modulation. Coming to the definition of pulse position modulation, the position of pulses will be varied. Carrier pulse train will be varied in accordance with the amplitude of modulating signal. And one more thing here, by PWM, we can achieve PPM, pulse position modulation. From PWM, PPM can be obtained. So first we will generate PWM signal, and from that PWM signal, either taking tail edge or starting edge or middle as reference, from that with a constant width, the output PPM can be obtained. Observe this waveform. Input is modulating signal and this is pulse. And PPM here, we can take as reference as tail edge or leading edge, we will call starting edge. This is leading edge and this is tail edge. Here you can observe we are taking a reference as middle. So from here with constant width, we have drawn these pulses. That is pulse position waveform. But with PWM only we can achieve that. Here we can achieve our PPM. Coming to the generation of PPM, it consists of comparator and monostable multivibrator just like PWM. From the comparator we can achieve our PWM as PWM signal is given to the monostable multivibrator so that we can achieve our PPM. Monostable multivibrator is a negative triggered circuit. At each tiling edge of PWM signal, the monostable output goes high. What is meant by multivibrator? Actually, it will act as an oscillator. In this monostable multivibrator, it consists of only one stable state and the other state as quasi-stable state. By these two states, wherever we require, we will be getting our output like pulse position modulation. As PWM is given as reference, from the PWM we will be achieving our PPM. Coming to detection of PPM, it consists of pulse generator and pulse reference pulse. Here we are using a flip-flop, SR flip-flop. From SR flip-flop we can obtain our output. So the circuit consists of SR flip-flop which is set or gives high output with reference pulses are arrived. Reference pulses are generated by a reference pulse generator. Flip-flop circuit is reset and gives between output and the leading edge of PPM signal. PWM pulses are then demodulated in PWM demodulator to get our original modulating signal. By this figure we can understand how can we achieve PPM so that if you join peak amplitudes, it will look like our input message signal. This is all about PPM, pulse position modulation, simple generation and detection technique of PPM, pulse position modulation. Thank you for listening.